following on from our previous two videos, we got to this stage here where we've created our function. We've created this function. It was given by this thing here. So what that means is we've created a machine where time here ticks along, which is our D. So when you input a D, it will then do whatever it has to do. It will do whatever it has to do, and it will spit out F. And this F here represents where the angle should be, where the angle of the particle should be. So for example, let's say time is ticking along like this. So let's say it's currently at 3. So you input a 3 into this machine, and then it will do whatever it has to do here. It will spit out an angle. So let's just say this angle here, it will spit out this angle here. So what that means is it will spit out this angle here. This is F here. This is F here. So it will tell you, oh, the particle should be here. So let's say time ticks along. It's ticking along. Let's say the time is currently 7. So you input a 7 in here, and then so you input a 7 in here. So that would be 7 here. It will do, this formula will do whatever it has to do, and it will work out this thing here, which is this bit here. So when you put 7 into the machine, it will spit out another angle, and let's just say this angle is this angle here. So once you've got this angle here, that will mean, oh, the particle must be right here, and so on. So this thing here tells you, so F tells you where the angle at which the particle should be at. So you input a D, and then it will do whatever it has to do. It will spit out an F. This F here represents the angle where the particle should be. So let's punch this. Let's punch this into Desmos. So jump to Desmos. Let's add expression. So F equals C sine square root, hang on, bracket, square root, SQRT, what was it? Hang on, let me think. It was 10 over L, and then the D, and then the D. We've got to add the D. Hang on, and then D. So basically, I am just punching this thing in here. Okay, so yeah, punch that into Desmos. So that's our F. So remember, hang on. Remember, you input a time D into the machine, it will spit out an angle F. So this F here is the angle, and it tells you where the angle of the particle should be. So this is an angle. Okay, F is an angle. So going back to our particle, so this is the D currently represents our angle for our normal particle. So we need to get rid of this and put a D, put an F in there, because F will incorporate the period, and it will incorporate the oscillation into the F. So hang on. So remember, hang on, let me just jump back to here. Remember, F takes care of the oscillation, which is C and negative C, and F also takes care that the time it takes to do one swing is given by this. So F takes care of the oscillation and the period of time. So this thing here takes care of this, the oscillation and the period of oscillation. So going back to here, change all the D's to F. So put an F in there. So now let's test it. So press play on D. So D will oscillate back and forth. Okay, hang on. Then, so D will oscillate back and forth. So if you move this, if you make the angle to be really small, the particle will slow down. If you make the angle really steep, really big, then the particle will speed up. So we incorporate the period of oscillation into there. So now we need to join our line. So we need to create our string. So looking at the particle, the x component of the particle is a bit complicated. So let me just extract that. So extract the x component of the particle. Cut, and then and then down here, and then paste. And then I'm going to call it U. So the whole thing, I'm going to assign the letter U to it. So U equals. So now going back to the X component of the particle, and put U in its place. And then I'm going to, so our Y component of our blue particle, which is this bit here, the Y component, is a bit complicated. So I'm just going to copy and paste it. Hang on. So I'm going to do the same thing right there. So hang on. So Control V for paste, and then I'm going to assign the letter V to it. V equals. And then going back to the Y component of our particle, and then get rid of the whole thing because it's complicated, and let's just put V in there. Oops. Hang on. Let's just put V in there. Delete the whole thing and just put V in there. So I've replaced our particle with U and V, so it becomes a lot simpler. So let's test it. Going to D, let D scan through. So as D is scanning through, it still works. So that's good. So U and V, currently the particle is at U and V. So now we need to create our string. So to create our string, add and then table. So we want to join a line from 0, 10 to the location of our particle, which will be U and V. So currently our line is dotted. We want to change that to a solid line. So lines solid there. So now press play. So now you've got our pendulum. So if you make the angle to be small, the pendulum slows down. If you make it really steep, it speeds up. You can change the radius. You can make it steeper of a smaller radius, and so on. So create this for yourself and play around with it. Okay?